Okay, guys, so what we're going to look at now is our basic exponential function and doing some of your general translations that we could do with any function. So we know what the general shape is, okay? Not very exciting. An intercept of 1 on the y-axis and an asymptote, okay, along the negative x-axis, okay, and forever growing, forever increasing, and forever uh, getting growing in y larger and larger and larger. Okay. Now we can do with this the whole sequence of translations that we could do with any function. Now remember, okay, we could flip it across the x-axis by by taking the opposite of the function. So that's going to be afforded to us with uh, slider A. So with slider A is going to simply go from 1 to -1. So if we take, and this is our basic function, y equals 2 to the x. If we then say y equals the opposite of 2 to the x, then we're going downward like this, okay? This is 2 to the x. This is the opposite of 2 to the x, okay? That is -2 to the x. It's not that the x, not that the base is negative, but it's being multiplied by a value of -2. So we're taking the opposite of the function, which is flipping it across the x-axis, okay? 2 to the x, the opposite of 2 to the x. So characteristics are changed drastically, okay, in that 2 to the x, our range is all positive, okay, and we're going through 1 on the y-axis, negative, the opposite of 2 to the x, our range is simply all negatives, okay, and our intercept is at -1, okay. Now that's flipping across the x-axis, which is brought to you by translation of taking the opposite of the function, opposite values of y, or just multiplying the existing function by a. Okay. Now we can also flip this across the y-axis, and we know we flip things across the y-axis by taking opposite values of x, taking opposite values of x. So opposite values of x can be controlled by, okay, the B slider here. So again, we're back to 2 to the x. I'm going to say now it's 2 to the -x, okay, and that flips it across the y-axis because the x has been replaced with its opposite. 2 to the x, 2 to the -x. 2 to the x, 2 to the -x. Exponential growth, exponential decay. And remember, we showed you that how we did that analytically, because 2 to the -x is the same thing as 1/2 to the x. Okay, so there's our exponential decay, which is basically, okay, uh, with a with the value of x being replaced with its opposite. Okay, here's 2 to the x. We're back to 2 to the x again. Okay, so we've talked about flipping it across the x-axis by taking the opposite of the function, just multiplying the entire function by -1, or flipping it across the y-axis by taking opposite values of x. Okay. Now, of course, we could slide it up or down or left or right. So if our G slider plus a D value there will allow us to slide it up with G positive. And of course, if we're sliding it up, then what of course is happening is we're moving the intercept up, we're moving the whole graph up, so therefore we're moving the asymptote up. So if we're looking at y equals 2 to the x plus 4, then we're going to come to rest on the horizontal line y equals 4, which will be our asymptote, okay, and we will have our um, our intercept 1 unit above there at 5, okay. Likewise, if our horizontal asymptote was to be at a negative value, okay, then we would, sorry, I got the wrong controller there, then we would have a d value of negative, okay? So having that, now this reads 2 to the x minus 2, which again is just shifting the whole graph 2 units down, which means if it's shifting it 2 units down, okay, we're shifting everything 2 units down. So the asymptote is now 2 units down, okay, and the intercept is 2 units down, all right? Um, so that's our horizontal, our vertical translations with the slider D. Let's go back to our unadjusted graph here, okay? Um, and that is 2 to the x, and there's our graph of 2 to the x, okay? Now we have a translation left and right, okay? When we're translating it left and right, it looks like we're altering the graph, but we're not, okay? So here is our um, 2 to the x graph. If now I say I want to, okay, make this 2 to the x plus 1, that is, I'm replacing x with x plus 1, okay? So if I say x plus 1, make that c value 1, okay, then what have I done, okay? If it says now, if now the c value is 1 and the new function is 2 to the x plus 1, I've moved my graph, okay, back 1 unit. And if I moved it back 1 unit, then the it's going to catch the intercept at a higher value, okay? And in fact, why is that 2? Is because now the exponent is, okay, 2 to the x plus 1. So when x is 0, I've got 2 to the first, which is my intercept now, okay? Uh, if I wanted my x value, if I wanted my graph 2 to the x, okay, to slide 1 unit to the right, then I would make my C value -1, okay? And then in making my C value -1, okay, I push my graph to the right, which means I'm catching the intercept at a lower value, which can be computed simply by saying when x equals 0, 2 to the -1 is 1/2. So that's my intercept there now. So we're going to go now and look at that as the PowerPoint presentation, and then you'll have a chance to work with these more in class. Okay. So now um, so now we're going to take, like I said, look at our translation. So here's a function which is representing all these things going on. Okay. We've got the function being multiplied by uh, a negative, which is sending it down, which is flipping it across the x-axis. Okay, we've got x being replaced with x plus 2, which means it's moving it 2 units to the left, and okay, we are translating it 3 units upward. Okay, so again, let's look at these things. Okay, we've got it reflected in the x-axis as indicated by the negative here. We've got to shift 2 units to the left as indicated by the plus 2, is x being replaced with x plus 2. And we've got to shift 3 units upward, brought to you by this, which we saw as a D slider on the Desmos. Okay, all right. We would like to be able to find the y-intercepts, okay, because then that would help us to graph it. So the y-intercept is, again, when x equals 0. So if x equals 0, okay, if x equals 0, we've got 2 squared, which is 4, and then that's offset by that, which is -4, plus 3. So we got a y-intercept of 1, okay, as rather a y-intercept of -1 as indicated here with the work, okay? Again, y-intercept is when x equals 0, okay? When x equals 0, all right, we're evaluating this. our order of operations is going to tell us that we square this first and then multiply it by -1. That's not -2 squared. That's 2 squared times -1. Okay? And of course, the horizontal asymptote we saw was at 3. Okay? And I think we can get the graph going here now. Okay? Um, so we have here's our y-intercept. Okay? And here it has been flipped over the x-axis. Our horizontal asymptote is at 3. We would probably like to find um, this x-intercept, but um, that's going to result in having to solve this equation. 3 equals -2 x to the power x plus 2, and we're not quite ready to resolve that, but we will do that in time. So there's some of your basic translations, okay, on a graph and how we can find the critical points that we need in order to graph it, okay? And we'll have a chance to do some more of these in class. All right, so that's that.